Okay. Hello guys, welcome back to the 360 DG's interview preparation session. I hope you are doing well. Without wasting any time, let's get into today's interview preparation session. So yeah, I have collected a few questions that has been asked in the interview. We'll go through those questions one by one. Yeah, very first question is, what is the typecasting? If you know the answer, please try to answer in the live comment session. And anyway, I'm going to discuss the answer in a minute. Yeah, let's discuss the answer. Yeah, typecasting is a way of changing one object from one data type to another data. Yeah, if you want to change from one data type to another data type, we'll be using the typecasting. Let's say you have an integer data type and you want to change to float. You can make use of typecasting and you can change one data type to another data. That is called typecasting. Well, let's move to the very next question. Yeah. What are the different types of machine learning algorithms we have? Just name them. What are the different types of machine learning algorithms we have? Yeah, Suprabhat, that is absolutely right. Sorry, I haven't seen the live chart. Yeah, converting data type from one data type to another data type. It is called typecasting. Supervised. Yeah, bye Chaudhary. Supervised and unsupervised. We have one more type of machine learning algorithms. Yeah, Suprabhat, yeah, that's absolutely right. Supervised, unsupervised, and reinforcement and reinforcement learning. Yeah, that is right. Venki, Venki. Yeah, we have supervised, unsupervised, and reinforcement learning. And one more thing, we have semi-supervised as well. If you want, you can research about it. But mainly we'll be having just three: supervised, unsupervised, and reinforcement. Let's move on to the next question. What is supervised learning? And if possible, give one example as well. If you know the answer, please try to answer in chat session. We will be discussing the answer in a minute. Yeah, Venki, we'll be having label data when it comes to supervised. Yeah, credit card for fraud. Yeah, it is one of the example of supervised. This algorithm. Yeah, Vaibhav, that is also true. Yeah, Rajdeja. See, when comes to the supervised, the labels will be given. The output variable will be known. Yeah, exactly. Supervised learning is a machine learning algorithm of inferring a function from labeled training data. The training data consists of training examples. So we'll be having the labels in the supervised learning. Okay, give examples of supervised learning algorithms. At least two. Give examples of supervised learning algorithms. Please try to answer in comment section. We will discuss the answer in a minute. Yeah, Venki, that's absolutely right. We will be having different algorithm that based on supervised learning. Among those, support vector machine, regression, naive Bayes, and decision trees. These are examples of supervised algorithms. Yeah. Yeah, that's absolutely right. Well, the next question, what is unsupervised learning? If you know the answer, just comment in your chat box. Anyway, we will be discussing this answer in a minute. Yeah, when come. Yeah, Vaibhav, that is absolutely right. No unlabeled data, output is not known, model is used to find insight. Yeah, that's absolutely right. Unsupervised learning is also a type of machine learning algorithm used to find patterns and the sets of data given. In this, we don't have any dependent variables or labeled to predict. We won't be having any labels when it comes to unsupervised learning. Yeah, let's move on to the next question. Give examples of unsupervised learning algorithms. Try to answer in chat session, live chat session, if you know the answer. Or else we'll be discussing in a minute. Yeah, Supravat, yeah, that is correct. Hierarchical and K-means comes under unsupervised learning. Yeah, Venki, that is absolutely right. Clustering, dimension reduction, association rules, network analysis. Yeah, these all comes under K-means clustering, principal component analysis, and hierarchical clustering. These are examples of unsupervised learning. Okay, moving on to next question. What is naive in naive base? What is naive in naive base? If you know the answer, answer in live chat session. or else we will discuss the answer in a minute. Yeah, let's discuss the answer for naive Bayes. What exactly the naive in naive Bayes? Yeah, we cannot really see in naive Bayes method. It is supervised. It is one of the supervised learning algorithm. It is naive since this algorithm by default as a take an assumption that all the input variables it has are independent of each other. So that is why it is called naive, and yeah, it is based on Naive-Bayes theorem. But by default, it will consider all the independent input variables are independent of each other. It doesn't matter whether those independent variables are related to each other or not. But it will by default it will consider that all the independent variables are independent of each other. Yeah, it will just assume. Yeah, it is an assumption. That is why it is called a naive Bayes. Naive. Yeah, exactly right. By default, it will assume that all the attributes are the input variables are independent of each other. Yeah, let's move on to the next question. What is PCA and when do you use it? If you know the answer, please comment in live chat session, or else we will discuss in a minute. Please try to answer in a comment section. What is PCA and when do we use it? Yeah, it is a principal component analysis. Yeah, Raviteja, yeah, it is a dimension reduction technique. Principal component analysis is a technique for reducing the dimensionality of dataset. At the same time, it minimizes the information loss. So when you have a multi-dimensionality problem, we'll be using PCA to reduce the dimensionality, and PCA also considers like minimizes the information loss. We are supposed to form different you can go through the answer. Yeah, but mainly we'll be using in order to decrease the dimensionality in the data set. Yeah, Venki, that is absolutely right. It will be used for dimensional reduction. When we have a multicollinearity issue, at that time also we will be using this technique. It is also used for reducing the noise in the data. Sometimes we might have data that is not needed, which is not informative, that can be eliminated using the PCA. Yeah. So let's move on to the next question. What is multicollinearity? What is multicollinearity? If you know the answer, comment in live chat session, or else we will discuss the answer in a minute. Please try to answer in live comment session so that you can, yeah, two or more independent variables are connected to each other, having the relation between. Yeah, Vaibhav, that is right. Ravteja, it should be in between independent variables. Those are input variables, you can say, input features. Yeah, let's discuss the answer. Multicollinearity occurs when two or more independent variables are highly correlated with one another in a regression model. Mostly we'll consider multicollinearity in a regression only because it will affect the model, the output labels. We'll be discussing that too in a minute. Yeah, let's move on to the next question. Yeah, this is very important question. Problems with having multicollinearity. What problems did multicollinearity causes in your model? That you need to explain. What problems multicollinearity causes in your model? Please try to answer for this question. What problems do multicollinearity causes to the model? Yeah, it affects the accuracy of the model, but what is the reason behind it? Why it affects the accuracy of model? What is the reason behind it? Let's discuss. No, Teja will discuss the answer. See, let me explain clearly. Let's say you have three variables x, x1, x2, and it is output. These are the input variables. So when weight of this x1 changes, let's say w1 is weight of x1. See, when we are changing the weights of x1, if there is a multicollinearity in between the independent variables, when it changes, this variable also changes. It's supposed to help to find out the y variable. I mean, the variation between input variable and output variable should be, we should consider that. But when we are changing the x weight of the x2 itself changing. So it will affect the output as well. Yeah, that is the reason it will affect the accuracy of the model when it comes to regression. Multicollinearity can be a problem in a regression model because we would not able to distinguish between the individual effects of the independent variable on the dependent variable. When the independent variable itself affecting, when we are changing the weights of that particular feature, then definitely it will affect by one. It doesn't. I mean, it affects in the sense it will affects on the accuracy. Yeah, yeah, Uma Mahesh, that is absolutely right. We can predict input variables like from x1 we will be predicting the x2 itself because both are similar. The collinearity will be is high, right? So that is why it affects the accuracy of the overall regression model. Regression model accuracy it will affect. So what is BIF in the machine learning? The next question, the very next question is, what is BIF in machine learning and when we will use it? Please try to answer in the live comment session. We will discuss the answer in 2 minutes. What is the BIF in machine learning and when will we use it? Please try to answer in the live comment section. What is the VAF? When will we use it? Okay, let's discuss the answer. VIF is variation inflation factor, variance inflation factor. We will use this, predict whether we have any collinearity in between the independent variables or not. The variance inflation factor quantifies the extent of correlation between the one predictor and the other predictor, means independent variables. It is used for diagnosing collinearity, multicollinearity. Higher values signifies if you have higher values of VIF, that can be considered as high collinearity, and if you have less value, that will be considered as a low collinearity. That we will see what is the value of those collinearity and all in the next question. Variance inflation factor. Please remember the answer for this. Answer for this question. It is one of the important. So let's say you have a multicollinearity in your model or in your data set. What will be the solution for the multicollinearity? How do you remove the multicollinearity from your data set? Please try to answer in live chat session. We will be discussing the answer in 2 minutes. Try to comment in the live chat session. What are the solutions for the multicollinearity? We have different kinds of solution, depends on the data set. So you should be aware of this. What will be the solution for multicollinearity? In this answer, we will discuss few. There are other solutions as well. You can explore those options. Yeah, let's discuss some of the solution for the multicollinearity. So the very first solution is you can drop the variable wherever you are finding the highest multicollinearity. Anyway, normally we don't really recommend dropping the variable. I mean, see, if you are dropping the variable, then you are losing the data. So it is not recommendable. You have to explore other options as well. Like you can do feature engineering, combine the multi. I mean, wherever you are having the collinearity, those columns you can do feature engineering on them, and you can try to convert into different feature. Or yeah, this is called feature extraction. Let's say example, if you have a collinearity in between x1 and x2, you might try using try to bring out the ratio, or let's let me explain you clearly. See, let's say you have distance. Let's say you have feature distance, time, these are very important, guys. Just listen. You have distance and time. These are two independent variables. Let's say you have correlation in between, high correlation in between these independent variables. So what you can do feature engineering using this. You can create one more column by using this only. Like we have a distance and time. You can make use of this column and you can create speed. In that case, you will be eliminating one column. I mean, eliminating one feature. It's the same, right? So the multicollinearity will, issue automatically will be gone. You are creating one feature from the whatever the features we have. This is called feature engineering. This is called feature engineering that you can perform on dataset. By this, you won't be losing any data. You are just converting the columns into new one. Yeah, Vaibhav, you can, but it depends on the data set. No, removing the complete column is not recommended. Sometimes, see, companies invest so much amount of money to collect the data. So we are simply removing the data doesn't make any sense. But if you have a good reason to remove the data or particular variable or a feature, you can do that. It completely depends on data frame to data frame, what kind of data frame you are working on. I hope you understood. We can apply ridge and lasso regressions as well. Somehow, what exactly ridge and lasso do? Wherever ridge and lasso regressions also do the same. It is kind of feature extraction technique only. If you have different independent variable x1 and x2, what exactly lasso and ridge regression do? If this feature is not important for model, it automatically decreases its importance. And in lasso, it will completely decreases its importance and it brings down to zero value. So in a way, it is also feature selection. We are completely removing the independent variable. When in case of lasso regression and in case of ridge, you are completely decreasing its importance by making those weights near to zero. In ridge, we are doing decreasing its importance by bringing weights into near to zero. In lasso, we are completely making its weights to zero. If that particular feature is not important. Yeah, so we can apply this technique as well. Or you can increase the sample size as well in order to solve this multicollinearity issue. Yeah, I hope you guys understood. Let's move on to the next question. How do we combine two data frames? What is the function we will use to combine the data frames? It is very simple question. Please try to answer. How do we combine? How do we combine two data frames? It is very simple question. Please try to answer in chat session. Venki, it is combining the data frames. Yeah, Uma and Vaibhav, absolutely. We can use concatenation function in order to combine two data frames. Let's move on to very next question. What is the main difference between classification, regression, and clustering techniques? What is the main difference between classification, regression, and clustering techniques? We have already discussed the similar question in the beginning itself. Try to answer in the live comment session. We will discuss the answer in a minute. Yeah, it is simple question, guys. Just try to answer in the comment section. It's very simple. Yeah, it's very simple. Both regression and classification are supervised and the clustering unsupervised. Regression and classification are type of supervised learning algorithm, while clustering is a type of unsupervised algorithm. Let's move on to the next question. What is the main difference between regression and classification? Sorry, classification techniques. What is the main difference between regression and classification techniques? Or we can say, when do we use classification and when do we use regression technique? Yeah, Venki, that is absolutely right. Clustering, we don't have any label data. Yeah, why is not known. Classification, why is not known. Yeah, absolutely. Venki. Yeah, when the output variable is continuous, then it is a regression problem. Whereas when it contains discrete values, it is a classification. Yeah, absolutely, Vaibhav. Yeah, that is correct. Yeah, that is true. Let's move on to the next question. Okay. Now let me ask this question. What is the primary purpose of histogram? What is the primary purpose of histogram? And you can answer secondary purpose as well. What is the primary purpose of histogram? It is basic statistic question. What is the primary purpose of histogram? Yeah, Vaibhav, absolutely. That is correct. The primary purpose of histogram is, yeah, that is correct. That is correct. To check the distribution of the data, how the data is distributed in the data frame, that we will do using the histogram. That is the primary purpose. And when it comes to the secondary purpose of the histogram, we'll see whether we have any outliers in the particular data frame or not. Uma, it is there in yesterday's. Yeah, yesterday's interview preparation is there in YouTube. Just check it, you will find out. It is there in YouTube. Yeah, Suprabhat, absolutely. The primary purpose of histogram is to see the distribution of data. And the next question is, what is the primary purpose of box plot? What is the primary purpose of box plot and secondary purpose of box plot? No, Raviteja, we don't use box plot for binning. Yeah, Vaibhav, absolutely. Primary purpose of the box plot is to find outliers. And what will be the secondary purpose? Yeah, Suprabhat, that is absolutely right. To check outliers are there not here. What will be the secondary purpose of the box plot? When it comes to secondary purpose of the box plot, you can check with the distribution as well using box plot. Name the very next question. Name two techniques for outlier treatment. Name any two techniques for outlier treatment. Vaibhav will be using box plot. The secondary purpose, you can see how the data is distributed. We can check using box plot as well. But the primary purpose is to find out whether you have any outliers in data or not. And the last question for today is what is the name just two techniques for outlier treatment. Yeah, Venki, that is correct. Trimming and miniaturization. And one more question. Vaibhav, see, in miniaturization, we don't replace with mean, median, mode. It depends. Upper limit and lower limit. We'll be deciding the upper limit and lower limit, right? We will be replacing with upper limit and lower limit, but not with mean mode, median mode. We won't be replacing with mean, median mode. We will be replacing with upper limit and lower limit. What is the difference between winterization and trimming? What is the difference between winterization and trimming? The last question, what is the difference between winterization and trimming? Yeah, Venki, that is absolutely right. When it comes to trimming, we will be removing all the outliers. Uh, Wherever we found the outliers, we will be removing in case of trimming technique. When it comes to winterization, we will be replacing those outliers with upper limit and lower limit. Yeah, Umesh. Yeah, Uma. Yeah, when comes to trimming the data, yeah, we will lose some data, but with winterization, we will be replacing with upper limit and lower limit, so we won't be losing any data when comes to winterization. Yeah, absolutely. I hope you guys learned something from today's session. Uh, yeah, this is all we have for today's session. We'll meet in the next session. Please try to revise these questions once again so that you can remember easily. And yeah, that's it. That's it, guys. Have a nice day and see you soon. Bye.